In our last set of videos, we introduced the idea of antiderivatives or indefinite integrals, which was the idea that the indefinite integral of, if the indefinite integral of some function f of x with respect to x dx is equal to capital F of x, then finding f prime of x, the derivative of capital F of x, would get us back to that original function f of x. So the idea that integration and derivatives are inverse operations of each other. Now we want to look at how we can calculate some of those antiderivatives and take those problems in the other direction. First, we'll look at constant functions. We've discussed how the derivative of a, which is just a constant or a coefficient in front of x, that derivative would just be a. Now what we want to do is reverse that, meaning that the indefinite integral or the antiderivative of a constant a dx, which tells us with respect to x, would be equal to ax, that expression that we started with initially. That means in example 1, if we want to find the indefinite integral of -5, that result would be -5x. We can check that answer using the process that we established last time. If we take the derivative of -5x, then we should get the function that we started off with. And in this case, we do. We get -5, which checks out. But what if we'd come up with a slightly different answer in example 1? For instance, if we said that this was -5x plus 2, well, then we could take the derivative of -5x plus 2, and we would get -5, which also checks out. Meaning we have two different answers that we've very quickly constructed for the result of that indefinite integral. And we could repeat this process. We could add a +4, a +5, plus whatever we wanted onto the end of that. And that would take us forever, because literally we could do that with an infinite number of numbers. So instead, what we do is add a +c onto the end of this antiderivative, or onto the end of this indefinite integral, where c is just an arbitrary constant and represents that infinite number of values that could be added on to the end of this. And still, when we checked that result by taking the derivative, this would still be correct. So we say that the indefinite integral, or the antiderivative of -5 dx is equal to -5x plus c, and that checks out because if we take the derivative of -5x plus c, we get -5 plus 0, because the derivative of a constant just becomes 0. So that checks out. What we've established then is that the integral of a constant becomes that constant times x, and then for any indefinite integral throughout all of these different antiderivatives and different indefinite integrals that we'll establish, we always add this plus c onto the end to represent the family of functions, the infinite number of varieties that we could establish by putting any constant that we want on the end of that antiderivative statement.